All right, our next team is called Team DojoCode. And I heard that some of their professors are in the audience, so no pressure.
Hello everyone, I'm John Butoto and I'm a member of DojoCode.
This is Deogratias Nyamhanga from UNF, Masters of Science in Data Science, also in DojoCode.
My name is Baraka Gotora from University of North Florida, Civil Engineering Masters, also from DojoCode.
Yes, so today we're going to present about forecasting housing displacement in Jacksonville using AI. And the problem statement that we chose, I'm going to start with the motivation for the problem statement. And the motivation is that, as we all know, in Jacksonville, there's a growing issue of housing instability that is caused by rising rents, expiring subsidies, and income disparities. And so the government lacks an established data infrastructure to help curb this problem. And that's why we decided to address this problem, and it's one of the problems that has been stated as problem case 1, which is to be able to use AI to identify and estimate neighborhoods vulnerable to housing displacement. So the major aim of this is to have a social impact. If we get a solution for this problem, we'll definitely have a social impact and be able to apply the knowledge that we have to create innovations in this sector. So in the solution that we came up with, what we did overall, we took the data that was provided, which was across 25 different cities, and we integrated that together. So we created one unified data set that we could use. And from there, we were able to extract some categories of features that we used to train an AI model using clustering algorithms and be able to establish a baseline feature that we can use to tell us about the displacement risk. And from there we were able to cross-validate that the results that we had across different cities, and the percentage accuracy that we achieved was 77.8%. And from this solution overall, we'll see that we can be able to use it to be able to tell the areas that are mostly affected by risk and which factors exactly that affect that influence the displacement risks. Yes, so as I said before, we collected data from 6 different data sources, 6 different folders, but the main data sources were census housing data, and we had data from data that involved the SNAP data about the nutrition data, and then and also other data. And from there we integrated that and we were able to create one comprehensive data source. And so the overall methodology that we used was we were able to identify 4 different features that we clustered together, and we were able to categorize the data that we had and create one new feature, which was what we call the displacement risk. And that was a discrete feature which had medium, low, and high as the categories in it. And from there, we used that to train another model that will be able to tell us which features exactly influence the displacement risk that we see. And we had a total of 98 features that we used to train that other model. And the train set was split. So we collected from a couple of similar cities that we included a couple of similar cities and also Jacksonville too to create the training set. And the test set, we tested it on Jacksonville because of time constraint. We were able to only test for Jacksonville. And the algorithms that we used were random forest, gradient boost, XGBoost, and LightGL.
From there, we made or generated an interactive map where we displayed or visualized Jacksonville with other peer cities, and we indicated where the neighborhoods with likelihood of being undergo displacement would be. So from the map, what you can get as an insight is the actual number of neighborhoods within the city that are likely to undergo displacement, and we can estimate what % of total neighborhoods that we have in a particular city would go displacement. But also from the map, we can see the distribution of these neighborhoods that are unlikely to undergo displacement, and maybe get some other similar characteristics in terms of geospatial characteristics. And we can look further into that because we might have data for like sensors and all that, but we don't have the geo characteristics or similarities between these cities. So by attaining the number of high-risk areas in a particular city, we took them and analyzed for all the peer cities with Jacksonville included, so as we can see the performance and how many or what % of city or neighborhoods in the city are likely to undergo displacement. As we can see from the rankings, Jacksonville is on the 5th position, and with the low %, it means that neighborhoods in Jacksonville are less likely to undergo displacement as compared to other cities, as you can see where Fort Worth is the last one with 6%. That means the population of neighborhoods in Fort Worth, then a larger % in that particular city has neighborhoods that are likely to undergo displacement. So that is the overview, insight that we can get from the genetic map that we created.
Yeah, so the next part is to analyze the performance results and the overall accuracy of the classification model on the classifying the displacement risk from low, medium to high. It performs with 78%, but this model has the ability to correctly identify high-risk areas by 90%. So the model overall can perform on 78% and 90% on identify all the vulnerable tracts. So also the clustering, we use the 4 features to create those 3 clustering groups. The clustering seal-out factor was 0.62%, so that we can have well-separated clusters. And the last part, the implication and conclusion. So from the model, we can get the most important features that contribute to the displacement risk. And these 5 are the ones that really contribute to the displacement risk in any area. So those are like the households that are receiving SNAP, median household income, and housing builds. Those are which are old, so they have risk of lead paint risk. Also, low-income renters, minority householders in HUD-assisted programs, and overcrowded housing units. And from these features that greatly contribute to the displacement risk of any area, we can provide 1 or 2 recommendations that can solve this problem, which is generally is to tackle all these features, but 1 or 2 that we can suggest is strengthen the income supports, invest in housing rehabilitation so that we can fix the problem of lead paint risk for the aging houses, and the last one is assisted federal programs that greatly contribute to the displacement risk, because some of the subsidies are expiring and those greatly contribute to the displacement risk. Thank you.
I can see that in the policy recommendation, you have some recommendation. Did you actually use that as your input to your model?
No. So the policy recommendation come from the features that greatly contribute to the displacement risk in the model. So the model gives us the most important features that generate if the displacement risk is high or low. So from tackling these features using this recommendation, we can be able to sort out the displacement risk in the high.
I think my question is that general business knowledge you applied, or actually you have, you have?
No.
Okay.
These are just recommendations based on the features.
On that, could you modify your solution in a way to if you change those inputs, to see what the outcomes would be? So that would be kind of a tack-on question. Could you use it to simulate the results if you actually put in your policy recommendations?
Yeah. So
Yes. So because we have a model, right? So if we create like a synthetic data, we can input that like using all the features. So say we
features that you identified. Could you just talk a little bit about if some of those features were engineered or if they came directly from files, or what you kind of learned from exploring the feature sets that went into the models?
yeah, so we had 98 features, and from feature importance and feature selection, 15 of the features were reduced due to high correlation. They had correlation of 0.95 and above, which highly correlated to other features, so we had to remove them. So ultimately we had 83 features, and after the model training, measuring the feature importance of each feature, these were the ones that contributed more. So they had more feature importance than the other ones.
And were any of those engineered features, or were these straight provided from the data files you guys received?
Yeah, so only one feature which we used in the second model was engineered. That was the one which we did the clustering for, and then we generated the measurement that we used, the displacement risk, which was categorical. So that one was engineered, but the rest of the features were from other files, and then we reduced the features using this technique. So using correlation, we reduced features until we had the final 83, which is yes.
Yeah, good job.